Today, we're grabbing the wheel and talking about steering kickback, that really sudden, jarring jolt that can travel from the road right through your car and into your hands. So let's break down what's actually happening under the hood.
I mean, it's a feeling that definitely gets your attention, right? You're just driving along, maybe you hit a pothole you didn't see, and bam, the wheel just snaps back at you. It's not just uncomfortable, it's actually a really critical message that your vehicle is trying to send you. So, what do we actually call this? Well, the official term is steering kickback. It's that immediate forceful feedback you get when one of your front wheels hits something it really doesn't like. A pothole, a curb, or even just a really rough patch of pavement. But why does this happen? See, it's easy to just blame it on worn parts, but the real answer is way more interesting. It's a fascinating chain reaction that actually starts with some pretty fundamental physics. So let's dive into the science behind that jolt. The entire event, every single time, starts right here. It begins with a concept that engineers call unsprung mass. Now, it might sound a little technical, but trust me, this is the absolute ground zero for the force that you eventually feel in your hands.
So what exactly is unsprung mass? Well, it's pretty much everything on the road side of your vehicle's springs. Think about your heavy wheel and tire, your brake caliper and rotor, the wheel hub. All that stuff is not cushioned by your suspension. It has to take the hit directly. Okay, so here's the magic moment. When your tire slams into a pothole, that entire chunk of unsprung mass is forced to accelerate, like instantly, usually up or sideways. And as good old Newton taught us, when you take that much mass and multiply it by that sudden, violent acceleration, you get a huge amount of force. And that force has to go somewhere.
And this shows you exactly where it goes. It's a chain reaction. The tire hits the bump, that unsprung mass accelerates, creating the force. That force then travels right through the steering linkage, we're talking the tie rod, into the steering rack, up the steering column, and boom, it kicks back at the steering wheel in your hands.
So you might be wondering, if this force gets generated every time I hit a bump, why don't I feel it all the time? Well, that's because a healthy car is specifically designed to absorb it. When you do feel it, it's a sign that some specific components have failed. So let's look at the mechanical culprits.
A huge part of the problem can be hydraulic. If air gets into your power steering fluid, it creates this spongy, compressible little pocket. And when that force hits, the air just squishes down, letting a massive jolt pass right through. A weak pump can cause problems too, because it can't supply enough fluid pressure fast enough to fight back against that sudden movement.
When you look at the whole system, it's designed to do two things: make steering easier for you and absorb all those forces from the road. Think of it like a big hydraulic cushion. But as soon as one of these parts wears out, it creates a weak link in the chain, and that jolt from the road finds the path of least resistance, which is straight to you. And really, your suspension is your first line of defense. Healthy shocks and struts, they're dampers. Their whole job is to absorb and dissipate that impact energy. Healthy joints and bushings hold everything tight and stable, but when they're worn out, they lose their resistance, they get all loose, and that impact energy just completely bypasses the suspension and shoots right into your steering components.
Okay, let's zero in on a really common suspect, the tie rod end. This little joint is the critical link that connects your steering rack to your wheel. It's what allows the wheel to pivot nice and smoothly when you turn.
So when a tie rod end wears out, it develops what mechanics call play. Basically, it gets loose. Instead of a nice, firm connection, you get this sloppy one. So when a bump forces the wheel to jerk sideways, that worn joint lets it snap violently instead of moving smoothly, sending a shockwave right back to you.
Now, if we move a little more inward, we get to the steering rack itself. This is really the heart of the system. It's what translates the spinning of your steering wheel into the side-to-side movement that actually turns your tires. If the gears inside wear out, or the bushings holding the whole rack get loose, you get play right at the source. Any force coming from the wheels isn't dampened at all. It just gets reflected right back up the steering column.
Now, for those of you with trucks and SUVs, you'll often find this part a steering damper. It's literally a small shock absorber built just for the steering system. Its one and only job is to soak up those sudden side-to-side jolts. So as you can imagine, when this part fails or wears out, that kickback you feel can get dramatically worse.
It's also important to note that not all vehicles experience kickback in the same way. The actual design of your car or truck plays a huge role in how much of that force you're going to feel. Let's look at a few real-world examples to see what I mean.
So why does a big, lifted 4x4 feel so much more kickback than, say, a family sedan? Well, it's kind of a perfect storm.
First, many of them have a solid front axle, which means the wheels are physically linked together. A jolt to one is instantly felt by the other. Second, those huge, heavy off-road tires. That's a massive increase in unsprung mass, and as we learned, more mass means more force. And finally, the alignment on these trucks creates more leverage for road forces to push back. It helps the truck go straight, but it also acts like a bigger lever, amplifying any kickback you feel.
And you know, the type of steering you have matters too. Most modern cars use what's called a rack and pinion system. It feels great, very direct and responsive, but that directness is a two-way street. It also transmits forces from the road back to the driver much more easily than older, less efficient steering box designs you'd find on some classic trucks.
Okay, so we've covered the physics, we've covered the parts. What do you do if you're actually experiencing this? Let's talk about diagnosis, and more importantly, why ignoring it can be seriously dangerous.
Here's a quick checklist of what you or your mechanic should be looking for. You gotta check for any looseness or play in the tie rods and ball joints. Inspect all those rubber bushings for cracks or damage. Get your wheel alignment checked, especially that caster angle. Take a look at the steering damper for any signs of fluid leaks. And hey, don't forget the simple stuff, like making sure the steering rack is bolted on tight and that your tires are in good shape. And please, whatever you do, don't just write this off as a minor annoyance. You can think of steering kickback as your vehicle's check engine light, but for the suspension and steering. If you ignore that warning, what starts as a small jolt from a pothole can escalate into something much, much worse.
The absolute worst-case scenario is a phenomenon with a terrifyingly accurate name: death wobble. This is where a single bump triggers a violent, uncontrollable shaking of the front wheels that you can only stop by slamming on the brakes. It's basically steering kickback caught in a terrifying feedback loop, and it's caused by the exact same worn-out parts we've been talking about this whole time.
So, the bottom line is this. Your steering wheel is one of the main ways your car communicates with you. It tells you what the road is like, what the tires are doing, and if it starts shouting at you with sharp jolts and kickback, it's probably a good idea to listen. So what is your car trying to tell you?